So the title for this presentation sounded a little boring. So I thought maybe something like achieving decentralized Zen in the Kubernetes era, or something like, Zen and the art of API management might be better. Let me expand on this. The fact of the matter is that no cluster is an island. In fact, one of the trends I've been noticing is that there's a little bit of a cluster sprawl out there with folks using Kubernetes clusters as a way to have a isolated span of control for the different teams and different subsection of an organization. Believe it or not, in past life, I even had a team come to me, and in this particular case, they were aerospace organization, and they were thinking about having Kubernetes clusters installed on satellites that they would be launching into space. So the point is that Kubernetes clusters don't exist on their own. Yes, there's going to be a lot of different applications deployed on a single Kubernetes cluster across different namespaces, having to interact with each other. And a solution like a service mesh solves the challenges of managing the interactions between these services handsomely. But there is traffic that needs to come from the outside of this cluster and go out from this cluster, starting with interactions with these other clusters that are out there that are potentially managed by other teams. But also, these services expose APIs that need to be used by actual end user devices, such as applications on mobile apps or web browsers, or APIs that are exposed to your partners, or APIs that are exposed for customers in public APIs for API productization use cases. So a cluster is really there to provide the underlying services in many cases for these higher order applications to be able to access them, or other clusters to be able to interact with them. Now, the challenge is this traffic needs to be managed. Why? Because, obviously from a security point of view, that's the obvious one. You don't want to be able to have anybody just interact with your APIs. Not any cluster be able to access those services, and not any partner to be able to just call it. You need to manage the security. It needs to be authenticated and authorized and properly logged. Also, if you just expose that, even if it is for cluster-to-cluster communication, those services just without any type of management, you can have issues where you don't know how much load you're going to get. And therefore, you could have the service go down because you just got too much traffic on it if you just have people discovering it by themselves and just calling it. And of course, cost management is continuously becoming a challenge for folks because once a Kubernetes cluster is set up, the management of the underlying compute leads to the implicit question of who manages the cost of that compute. And therefore, if you just allow traffic to come in unprecedented from the outside, one needs to think about how you manage the cost as well. So how do you address this? Typically, one answer could be, well, let's just throw a gateway in the middle. Throw a good old API gateway in the middle and have every service that needs to be exposed from any given cluster for usage by other clusters or by some of these external type of services I mentioned, have to call it through this central gateway. Well, it turns out this is causing a lot of frustration. Why? Because that central gateway needs to be managed typically by a team of their own, because it spans all of these different clusters. Also, the change management that this implies is now suddenly that every time you're exposing a new service that needs to potentially be consumed externally, you need to make sure that that gateway is configured properly. And this, traditional central gateway type models are not really amendable to dynamic changes that are more prevalent with the type of life cycle that happens for services that you have on your Kubernetes environment. Often manual ticket-based models. And then last but not least, This type of central approach leads to a, what we used to call spoff and spot, a single point of failure and a single point of traffic or single point of bottleneck, or SPOP. So at the end, you end up with a slower, more brittle, and less secure because you end up bypassing these types of management elements, and therefore generally not zen and more frustrating situation. So what's the solution? Well, what if there was a world where you could have the ability to expose your services with appropriate authentication, authorization, rate limiting, and other management concerns in a completely decentralized way, so that each team could make parallel configuration changes through the CI/CD pipelines, that each team could manage their own gateway, and yet have the ability to have all of these traffic management capabilities. So you have a more adaptable, everyone can go at their own pace, a more resilient environment because everybody is able to have those capabilities done right away as changes occur, and therefore more secure as well. In general, a more zen world of service management. What if that you could do that? Well, it turns out that's one of the things that, the main thing really that Kubernetes Ingress allows us to do. And Ingress, as everyone I think knows here, is the resource that allows us to expose a service to external entities from the cluster. And a controller, an Ingress controller, is responsible for fulfilling the Ingress rules. So the Ingress controller is really the implementation behind the Ingress. And it turns out that the choice of Ingress controller you make is critical to determine whether you are going to be able to achieve that state of zen or not. Now at Kong, we hear quite a bit, we live and breathe these types of problems around service management, connectivity management in general. And I wanted to share with you what our customers, our users, our community users and our customers have been telling us about what they need and expect around their Ingress needs. Let's tackle each of these one by one. First and foremost, the primary need is that the operations of the Ingress need to be done in a Kubernetes-native way, which really means exposing everything through CRDs, so that you don't have to call external APIs to configure that particular rate limiting rule or that particular auth key application. The second is, you don't want your Ingress controller to actually have a big stateful footprint with its own runtime. That leads to a heavier weight environment. All state ideally should be managed the Kubernetes way and through etcd. Third thing is the ability to manage access to that Ingress and configuration access control through Kubernetes RBAC. Again, more Kubernetes nativeness. Going to the other side of the slide. Now, the Ingress is there not just to pass through traffic or just to do routing. Really, it's there to do full-fledged API management for all of your services. So the ability to do rate limiting, the ability to create specific consumers, named consumers, and have rate limiting on a per consumer basis. The ability to apply authentication with an external IDP, for example. All that is traffic management capabilities that have been traditionally done by centralized API gateways that now need to also be available at the Ingress level with all these other properties present as well. Another one is the ability for it to act as an operator, or for its lifecycle to be managed through the operator pattern. So how do you do the upgrades? How do you make sure that there's a reconciliation loop and you can do a GitOps model of change? All of these are well satisfied through a Kubernetes controller that allows us to have the operator pattern satisfied. And so that's a lot of things that a big element of what has been requested by a lot of our community members. And then finally, the Ingress itself doesn't exist in an island. Integrating that with your Prometheus environment for better observability, having it work with the different service meshes that are out there is a priority. And so as we've been listening to our customers, that's how we have been at Kong evolving the Kong Ingress controller, which we affectionately call K4KS. And if you go through the different elements that I outlined here, we expose all of the capabilities through CRDs. It is fully integrated with etcd. All of its capability, all of its authentication access control is done through RBAC. One of the things that's really exciting about the Kong Ingress controller is that there's hundreds of Kong plugins out there that allow for traffic management, and it supports all of them. We have an operator that allows you to have that reconciliation loop and perform GitOps, and it's well integrated into the cloud native ecosystem with out-of-the-box integration for Prometheus, integration with Knative so that you can act as an ingress for the Knative serverless stack, as well as integration with Kuma, the service mesh from Kong, as well as Istio. So I wanted to share with you what we call the golden use case, the end-to-end use case that our customers typically use for managing the lifecycle of their services. And it's all about having developers work on the spec of the API for HTTP APIs, that's the Open API spec, and perform all of the changes through that spec and the configuration even of the ingress through that spec typically. And then changes are done through typical Git, PR. When the change is committed, the CI pipeline then can leverage either the operator, if we are dealing with an ingress, or in a non-Kubernetes environment, a tool called DEC, which is an open source project by Kong, that enables non-Kubernetes environment to have some of the properties we just talked about from an ingress, and therefore applied in a GitOps native manner. So that's the end-to-end use case. I wanted to very quickly show you how this all comes together, just so that we don't make it just a slide meeting here. So let me show you quickly. This is Insomnia. This is an open source project also by Kong that enables API-based design. And so I'm going to show you a Hello World API that has a backend implemented right now on EKS Fargate cluster. So if I switch to debug mode, I can try to actually in design mode. One of the things I mentioned is generation of configuration. So from the Open API spec, I can generate the Kong gateway or the ingress spec, and have that be the source of truth for applying the changes to the actual gateway. If I go to the debug mode, I try to call this API. It's not working because it has an ingress in front of it protecting it. So if I say, hello, Cloud Native or Camp Cloud Native, well, that should still not work. But if I give it a key, because it's protected, it should work. All right, let's look behind the hood here. What's going on, right? So if I look at what's actually happening, we've got an ingress that is protecting the actual service, which would be behind a different address. And I can actually go and query the CRDs of the ingress and see that there's a consumer. And if I actually describe that consumer, I'll know that it has a key, and even see that there are plugins that are applied. So if I do a description of that plugin, I should see the exact rate limiting rules, for example. So everything is queryable through Kubernetes constructs. So you can see here all of the rate limiting aspects. So with that, Leishan, that concludes my presentation. In this deck, there's also some resources for you to follow up on if you're interested to find out more. Thank you very much for being a great audience, and looking forward to seeing some of your questions on the Slack channel. Thank you.